At 1400 hours on June 19, 1944, Lieutenant Commander Jimmy Flatley watched his radar screen light up with the largest formation of Japanese aircraft ever assembled for a single attack. 268 planes, organized into 4 separate waves, all of them heading directly for Task Force 58. The Americans called what happened next the Great Marianas Turkey Shoot. The Japanese called it a disaster they could not explain. Their pilots were flying the same aircraft they had used to dominate the Pacific in 1941 and 1942. Their tactics were sound. Their commanders were experienced. But something had changed in the air over the Philippine Sea that they had not accounted for, and that their intelligence had not warned them about. A machine built in a factory in Bethpage, New York, that their best pilots had started calling the Grumman Zoom. This is no man's land. Hit subscribe and turn on notifications. New documentaries drop every single week, and this is one story you do not want to miss. To understand what the Hellcat meant to the Pacific War, you have to understand what the Zero had done to American aviators in the 2 years before it arrived. The Mitsubishi A6M0 was not simply a good fighter aircraft. It was a revelation. When it appeared over Pearl Harbor and the Philippines in December of 1941, American pilots encountered something their training had not prepared them for. A carrier-based fighter with a range of over 1,500 miles, a climb rate of nearly 5,000 feet per minute, and a maneuverability that allowed it to outturn virtually every aircraft in the American inventory. The Zero had been designed by Jiro Horikoshi under constraints that forced radical engineering decisions. It was built light, extraordinarily light, by eliminating the self-sealing fuel tanks and the pilot armor that American aircraft carried as standard equipment. A Zero weighed roughly half what a comparable American fighter weighed. That weight difference translated directly into performance that American pilots found bewildering the first time they encountered it in combat. In a turning fight below 15,000 feet, the Zero could get behind almost anything it encountered. American pilots flying F6F Wildcats quickly learned that trying to match a Zero in a turning engagement was a death sentence. The ones who survived the first months of the war survived because they learned to run, to use the Wildcat's superior diving speed to disengage from a fight they were losing, and to fight only on terms they could control. For 2 years, American naval aviation operated under the shadow of the Zero. The kill ratios told the story plainly. In the first 18 months of the Pacific War, the Zero and its pilots killed American aviators at a rate that the Navy could not sustain if the war lasted much longer. Something had to change. Grumman Aircraft in Bethpage, New York, was given the contract to build the change. The design brief that Grumman received in June of 1941 asked for something specific, not a Zero killer that outturned the Zero or outclimbed the Zero or tried to beat the Zero at its own game. The Navy had learned from bitter experience that trying to copy Japanese design philosophy meant copying Japanese weaknesses along with Japanese strengths. What the Navy wanted was an aircraft that could kill Zeros without fighting like a Zero. Grumman's answer was the F6F Hellcat, and it was built around a single decision that shaped every other characteristic of the aircraft. The Pratt & Whitney R2800 double WASP radial engine, 2,000 horsepower. It was the largest, most powerful air-cooled radial engine in production in the United States in 1942. And Grumman built the Hellcat around it the way you build a house around a foundation. Everything else was sized to match what that engine could do. The fuselage was wide enough to accommodate the engine's 18-cylinder configuration. The landing gear was strengthened to handle the weight of an aircraft built to survive carrier landings at combat weight. The wings were folded for carrier storage, but thick enough to house 650 caliber Browning machine guns with enough ammunition to sustain fire for 30 seconds of continuous shooting. The pilot sat high and forward in a cockpit designed for visibility in all directions, and was protected by armor plate behind his seat and a bulletproof windscreen in front of him. The fuel tanks were self-sealing. The aircraft was built to take punishment that would destroy a Zero and keep flying. The result was a machine that weighed 15,400 pounds fully loaded, more than twice what a Zero weighed. But it had 2,000 horsepower to move that weight. And what 2,000 horsepower could do to a heavily built aircraft was something Japanese pilots had not yet encountered when the first Hellcats appeared in the Pacific. The Hellcat entered combat over the Pacific in September of 1943 over Marcus Island, and the initial engagements gave American naval aviators their first concrete evidence that something fundamental had shifted in the air war. The pilots who flew those first missions reported the same thing in their after-action debriefs. The Zeros could not run from the Hellcat. For 2 years, the tactical reality of the Pacific Air War had been that a Zero could disengage from any fight it chose to lead. Its lightweight and powerful engine gave it a climbing speed that no American fighter could match, and climbing away from a fight was how a pilot survived when the odds turned against him. The Hellcat changed that calculation entirely. Above 10,000 feet, the Hellcat climbed faster than the Zero. In level flight above 15,000 feet, the Hellcat was faster. In a dive, the Hellcat was faster still. And its heavier, stronger airframe could sustain speeds in a dive that would tear the lighter Zero apart at its rivets. A Zero pilot who found a Hellcat on his tail had fewer options than he was accustomed to having. He could not simply climb away. He could not dive away. He could try to turn, and in a slow-speed turning fight below 10,000 feet, the Zero still had advantages in certain conditions. But American pilots had spent 2 years learning not to fight in slow-speed turning fights below 10,000 feet. They had developed the boom and zoom tactic to a level of institutional sophistication that the Japanese had not matched. Dive from altitude, attack at speed, climb back to altitude before the enemy can respond. The Hellcat was built for exactly that tactic, and the combination of a superior airplane and a proven tactic against which the Zero had no reliable answer began producing kill ratios that had never been seen in the Pacific Air War before. The Japanese pilots who survived early encounters with the Hellcat did not call it by its American designation. They called it the Grumman Zoom, and the name was not accidental. It described the specific tactical experience of fighting the aircraft from the Japanese side. A Hellcat pilot would appear above and behind, diving at high speed, fire a burst, and climb away before the Zero pilot could bring his own guns to bear. The engagement lasted seconds. The Hellcat was gone before the Japanese pilot could fully react. Then it would appear again from a different direction, diving again, firing again, climbing away again. The Japanese pilots who debriefed after early Hellcat encounters described a consistent experience of feeling unable to fix the American fighter in their sights long enough to fire an accurate burst, while the American aircraft seemed to be able to appear and disappear at will from altitude. The zoom in the name referred specifically to this climbing exit from an attack, the ability to convert the speed of a diving attack back into altitude in a climbing arc that the Zero simply could not follow at any altitude where the Hellcat chose to fight. American pilots were taught to think of altitude as stored energy and speed as spent energy, and to manage the conversion between the two as the fundamental tactical currency of air combat. A pilot who maintained altitude advantage over his opponent maintained the initiative. He could choose when to attack and when to disengage. The Hellcat gave American pilots the ability to maintain altitude advantage over Zeros in a way no previous American carrier fighter had managed to do, and the Japanese pilots who faced it understood what had changed, even when their commanders in Tokyo were slow to admit it. By the summer of 1944, the statistical record of the Hellcat in combat was producing numbers that American naval commanders found almost difficult to believe, even as they were reading them. The F6F Hellcat achieved a combat kill ratio of 19-1 against Japanese aircraft across the entire Pacific theater. For every Hellcat lost in aerial combat, American pilots destroyed 19 Japanese aircraft. The ratio against the Zero specifically was even higher in certain engagements and certain theaters. The Battle of the Philippine Sea on June 19th and 20th, 1944, the engagement that American aviators called the Great Marianas Turkey Shoot, produced the most dramatic single demonstration of what the Hellcat had done to the balance of air power in the Pacific. 268 Japanese aircraft were launched in 4 waves against Task Force 58. American Hellcat pilots met them in the air and destroyed them with a completeness that stunned both sides. The Japanese lost approximately 300 aircraft in 2 days of fighting. The Americans lost 29. Across those 2 days of battle, Japanese naval aviation lost not just aircraft, but the trained, experienced pilots who had formed the irreplaceable core of their carrier air groups. These were not men who could be replaced on any reasonable timeline. Japan had built an extraordinary generation of naval aviators in the 1930s and early 1940s, men who had learned their craft in the war over China and refined it in the first 2 years of the Pacific Campaign. By June of 1944, most of them were gone. The pilots flying the aircraft that the Hellcats met over the Philippine Sea were, in many cases, men who had been in flight training 6 months earlier and who knew it. The single engagement that most clearly illustrates what the Hellcat could do in the hands of a trained pilot belongs to Lieutenant Alexander Vraciu on the morning of June 19, 1944. Vraciu was already an ace with 15 confirmed kills before that morning. He had been flying Hellcats since their introduction to the Pacific Theater, and he understood the aircraft with the intimacy that comes only from hundreds of hours of actual combat flying rather than training. On the morning of the Turkey shoot, Vraciu was leading a section of Hellcats at 18,000 feet when his wingman spotted a formation of Japanese dive bombers below them at 12,000 feet. 40 Japanese aircraft in a single formation, heading toward the American fleet in a tight, disciplined formation that suggested their pilots were well trained by the standards still available to Japan in mid-1944. Vraciu counted them, assessed the geometry of the interception, and dove. What followed took less than 8 minutes from the first firing pass to the last. Vraciu destroyed 6 Japanese aircraft in a single sustained engagement through the formation, then climbed back to altitude and assessed the remaining threat. 6 kills in 8 minutes. He returned to his carrier with less than 10 rounds of ammunition remaining per gun. The debriefing officers who interviewed him afterward noted that his description of the engagement was almost mechanical. He talked about angles and speeds and ammunition management and the wind conditions, the way an engineer discusses a problem he has already solved, rather than the way a man talks about the experience of killing. The aircraft had made it possible to think that clearly under fire, because the aircraft was so superior to what it was fighting that the pilot could focus entirely on execution rather than survival. The aircraft on the other side of these engagements in 1944 were not the same Zeros that had dominated the Pacific in 1941 and 1942. The Zero had been improved in various incremental ways across the course of the war, but its fundamental design philosophy had not changed in any meaningful way. It was still built light, still relied on maneuverability rather than speed and firepower as its primary tactical asset, and still lacked the pilot protection that American doctrine had concluded was essential for sustained combat operations. The Japanese had also introduced newer aircraft to supplement and eventually replaced the Zero, including the Mitsubishi J-2M Raiden and the Kawanishi N-1K George, both of which were faster and more heavily armed than the original Zero design and represented genuine improvements in Japanese fighter capability. But these aircraft faced the same problem that all Japanese fighter design faced in 1944, which was not primarily a problem of aircraft performance or design philosophy. It was a problem of pilot quality and pilot supply. The Japanese naval aviation training program that had produced the generation of exceptional pilots who fought so effectively in the early years of the war had been destroyed by the pace of attrition in the Pacific. The pilots lost at Midway, at the Coral Sea, over Guadalcanal and the Solomons, over Rabaul and the Marianas had represented years of irreplaceable training and combat experience. Japan had never built the training infrastructure to replace them at the pace the war was consuming them. By mid-1944, Japanese carrier air groups were entering combat with pilots who had 200 hours of total flight time against American carrier pilots who typically had more than 500 before they saw combat. The Hellcat was not only a better aircraft than what it was fighting, it was also being built at a rate that Japan could not begin to approach or match. Grumman's factory in Bethpage, New York, had been converted to Hellcat production with an efficiency that became one of the defining industrial stories of the entire American war effort. At peak production in 1944, Grumman was delivering more than 500 Hellcats per month to the Navy. Over the entire production run of the aircraft, from 1942 to 1945, Grumman built 12,272 Hellcats. Japan's total production of all naval fighter variants over the same period was substantially lower, and the attrition rate of Japanese aircraft in combat was substantially higher than anything the Japanese production system had been designed to sustain. The arithmetic of those two facts combined was brutal and decisive. Every month, American factories were delivering more Hellcats than Japan was losing in combat and building replacements for. Every month, Japan was losing experienced pilots faster than its training pipeline could replace them with men of comparable quality. The crossover point, the moment when the American industrial advantage became militarily decisive rather than merely statistically significant, came sometime in 1943, and by mid-1944 the consequences of that crossover were visible in every combat statistic coming out of the Pacific theater. The Hellcat did not win the air war over the Pacific alone. The Corsair, the P-38, the logistics chain that kept aircraft fueled and armed across thousands of miles of open ocean, the industrial base that produced all of it, all of these were part of the same system. But the Hellcat was the sharpest and most visible edge of that system. The Battle of the Philippine Sea effectively ended Japanese carrier aviation as an offensive force capable of challenging American naval dominance in the open Pacific. After June of 1944, Japan never again assembled a carrier air group of sufficient quality and size to threaten an American task force in conventional air combat. The aircraft carriers survived the battle. At least some of them did. The Taiho and the Shokaku were sunk by American submarines during the engagement, but enough Japanese carriers survived to maintain the appearance of a carrier force. What did not survive, and could not be replaced, were the pilots who should have flown from their decks. The response that Japan developed to this situation revealed how completely the strategic situation in the air had changed by the autumn of 1944. Unable to match American aircraft and American pilots in conventional air combat, Japan turned to the only asymmetric option their commanders believed was available. The Kamikaze program, officially organized in October of 1944 under Vice Admiral Takejiro Onishi, was not a decision made from strength or confidence. It was a decision made by commanders who understood that conventional combat could no longer produce the results they needed, and who concluded that a single pilot willing to give his life could do more damage to an American fleet than a trained pilot fighting to survive and fight again. It was, in its own terrible and deliberate way, an acknowledgement that the Hellcat and the aviators who flew it had won the air war. The Japanese had conceded the conventional air battle entirely and were searching for a way to keep fighting and killing despite having lost it. The Grumman Zoom had done exactly what it was built to do. 268 Japanese aircraft launched against Task Force 58 on June 19, 1944. American Hellcat pilots destroyed them at a rate that Japanese commanders could not explain in their after-action reports and could not reverse in the months that followed. The pilots who called it the Grumman Zoom understood what they were facing. Their commanders in Tokyo took longer to accept that the aircraft and the industrial system that had built 12,000 of them had already determined the outcome of the air war over the Pacific before most of those commanders were willing to admit it. If this video meant something to you, hit the like button right now. It is the single best way to push this story to someone who needs to hear it. Subscribe if you are not already here. Drop a comment and tell us where you are watching from and whether anyone in your family served in the Pacific. We will see you in the next one.